Hello everyone, welcome to the science series, and today we are going to cover the third chapter of the science textbook, which is chemical reactions and equations. So first of all, what is a chemical reaction? So in our everyday life we see many chemical reactions happening. It's not like a complex procedure. So melting of ice into water, formation of water into ice, or the formation of curd from milk, or we keep naphthalene balls, their size reduces as the day passes, they sublime into air. All these are chemical reactions. The ripening of a fruit, it is also a chemical reaction, a type of chemical reaction. So there are various types of chemical reactions and how that reaction takes place. What are the components of a chemical reaction, that we will understand through our video. Okay. So in chemical reaction, there are basically three people who are doing their work. Okay. So the first one is the reactant, catalyst and the product. So what are reactants? So whatever substances that take part in the chemical reaction or they undergo the change, they are called as reactants. And after the chemical reaction, the substance which is formed, it is called as the product or products. There can be a single or multiple product of a chemical reaction. So in a chemical reaction, bonds are broken of the reactants and then new bonds are formed, and with that new bonds we get the products. Okay, so reactants are always on the left side of the chemical reaction and products are always at the right side of the chemical reaction, and we see a arrow in the center of every chemical reaction. So always there is an arrow, and above that arrow we write the catalyst or the heat, temperature or pressure conditions when that reaction is going on. So if we write water is converted into ice, so here the temperature will come 0 degrees or minus 0 at 0 degrees the water is converted into ice. So here we'll mention 0 degrees. Okay. So and what is a catalyst? Catalyst is a substance by which by only its presence it accelerates the reaction. So it doesn't take part in the reaction, but it accelerates the reaction or it increases the rate of converting the reactants into products. So we can take an example like we study at our home. So if we study alone, we don't study much, but if we have our parents sitting by our side, we study more. So they act as a catalyst. So in the same way, they don't participate in our studies, but by their presence we study more. So by the presence of the catalyst, the reactants react fastly and they are converted into products. Okay, so we'll see some chemical reactions and how to write a chemical equation for any reaction. Okay, so I'll write some common equations which we know. So we have carbon dioxide which is very abundant in our atmosphere. So we'll write the formation of carbon dioxide first. So carbon dioxide. So what do we know about carbon dioxide? It has carbon and dioxide, which means two oxygen atoms. So oxygen atom always exists dioxide. So always two oxygen atoms form an oxygen molecule. One oxygen atom cannot exist. So we will write carbon plus oxygen gives carbon dioxide. But this I have written their names, but while writing chemical equation we have to write the specific molecular formulas or the chemical formulas, and we have to also balance the equation. Now what does balancing the chemical equation mean? We will see it in our further video. What is balancing the equation? So first of all, I'll write a normal equation of formation of carbon dioxide. So the symbol for carbon is C. Oxygen, I told you it doesn't exist alone. It always exists as a O2 molecule and it is converted into CO2. So this is a first common reaction that we all know. Carbon plus oxygen, it gives CO2. Then the second one, which is very common, is water, as 90% of our earth is covered with water, we'll see how water is formed. Water is formed with hydrogen and oxygen atoms. So the molecular formula of water is H2O, and hydrogen also cannot exist single, so it exists as a molecule. H2 plus O2, we get water. The third equation we can take is sodium plus water. So when sodium reacts with water, it forms NaOH and it gives H2 gas. Okay. So in these chemical equations, we can find which are the reactants. So whatever is written on the left side, they are all reactants, and whatever on the right side, they are all the products of the chemical reaction. So here hydrogen plus oxygen makes water, sodium reacts with water to form sodium hydroxide, and hydrogen is liberated. Now we have to balance this equation. So what do you mean by balancing? Balancing is we have to keep same number of atoms on the left side of the arrow and the right side of the arrow. So we have to count the atoms and see if they are equal on both the sides. So first, let's take carbon. So we have only one carbon on the left side of the arrow and one carbon at the right side of the arrow. So carbon is okay. Oxygen we have 2 atoms, and oxygen we have 2 atoms on the left and right side. So this equation we can say it's a balanced equation because the number of atoms on the both sides are equal. Now let's look at the second equation. We have 2 hydrogens on the left side and 2 hydrogen atoms on the right side. So hydrogen is okay, but oxygen, there are 2 oxygen atoms on the left side but only 1 atom on the right side. So what do we do to balance the equation? We have an equal number of oxygen atoms. So we can add a coefficient before the molecule. So to make 2 oxygen atoms, we can just add 2 here. Before the molecule, we can add a number. So by adding 2, we get 2 oxygen atoms, but the hydrogen becomes 4. 2 hydrogen into 2, 4. So to balance 4 hydrogen, we also add 2 here. So now the equation is balanced. 4 hydrogen, 4 hydrogen. 2 oxygen, 2 oxygen. Now the equation is balanced. So let's come on to the third equation. Sodium plus water, sodium hydroxide plus hydrogen. So let's count first Na. So sodium is 1 on the left side and sodium is 1 on the right side. Then hydrogen, there are 2, but here we can see 1, 2, 3. There are 3 hydrogen atoms, so it is not balanced. And oxygen, we have 1 on the left side and we have 1 on the right side. So oxygen is balanced, but hydrogen are not balanced, and we can have only a even number. We cannot create 3 hydrogen atoms here. So we will make these 3 hydrogen atoms as 4. We will add 2 in front, so 2 hydrogen and 2 hydrogen, total 4. So we can make here 4 hydrogen atoms by adding 2. 2 into 2, 4. So 4 hydrogen, 4 hydrogen, equal. Now we'll again check for oxygen. Now here 2 oxygen atoms are there, and by adding 2, we also made 2 oxygen atoms on the left side. So oxygen is equal. Now let's check for sodium again. There is here 1 sodium atom on the left side and 2 sodium atoms on the right side. So to balance, we will add 2 on the left side. Now you can see the equation is balanced and the same number of atoms exist on the left side and on the right side. So this is the way to balance an equation. There may be questions in the exam that they give you any equation and they tell you to balance it. So you can balance it by counting the number of atoms and adding sufficient or appropriate coefficients to balance the atoms on both sides of the equation. Okay, so this was the way to write the chemical equation. Now let's move on to what are the types of chemical reaction. So basically there are 4 types of chemical reaction. Broadly they are classified into 4 types, but there are many types. Here first is the combination reaction. The name itself suggests that 2 elements combine, 2 reactants combine, and they form only one product. Here it is clear. See, there are 2 reactants and it is clearly forming a single product. Hence it is called as combination reaction, combination of 2 reactants. So the first reactant is ammonia and second is hydrogen chloride. So when ammonia reacts with hydrogen chloride, we get ammonium chloride as our product. Okay. The second reaction is decomposition reaction. Now the name itself indicates that a single product is decomposed into two or more products, or a single reactant is decomposed into two or more products. So here the reactant is sugar. So this molecular formula C12H22O11 is for the sugar that we everyday use, we eat. But when this sugar is subjected to heat, it decomposes into carbon and water. So why have I added 12 here and 11 here to balance this equation? So as you can see, the number of atoms of carbon, hydrogen, oxygen are balanced on the left as well as right side. Therefore, I have added these coefficients here. So this is the decomposition reaction where one reactant, it decomposes into two or more products. The third reaction is displacement reaction. So in this reaction, there are two reactants and one of the reactant takes place of one element from the other reactant, and then the same two products are formed. So here we can see copper sulfate and zinc. So as zinc is more reactive, it forms zinc sulfate and copper is given out. So this is the displacement reaction. It is called displacement reaction because zinc replaces copper from copper sulfate. So an element which is more reactive, it replaces the less reactive element. Zinc is more reactive, therefore it replaces copper and we get ZnSO4, that is zinc sulfate. Then the last reaction is double displacement reaction. It is similar to displacement reaction, but in double displacement reaction, all the elements of both the compounds, they exchange their positions and they form a new product. So here we can see NaOH, sodium hydroxide plus H2SO4, sulfuric acid. So from the sulfuric acid, the hydrogen is gone and sodium replaces it. So we get Na2SO4, sodium sulfate and water. So this was the double displacement reaction, and this was all about the chemical reactions and equations. Hope you have understood all the reactions and how to balance a chemical equations. If you have any doubt, you can comment down in the comment section. Thank you.